Hello everyone. In today's session, we'll be looking after cloud programming. That is how Google will be using various sort of methods and also architectures in order to provide the programming support to all the users. So first, we'll be discussing about the program support for Google's App Engine. If you look after how Google operates, here we'll be having some hundreds of commodity servers. So commodity servers are nothing but the the servers which are available in the market at a very lower cost when compared to the other systems. Here, what happens is that some hundreds of commodity servers together they'll be called as one particular cluster. And Google's App Engine will be using the concept of distributed file system. That is, the files that are stored in the Google's App Engine will be distributed among various sort of servers. So here Google what it does is that they'll be using some commodity servers, and these commodity servers are cheap and they can be made to scale horizontally. That is, we can add any number of systems to a particular cluster. And there are certain sort of risks by using these commodity servers also. That is sometimes the risk or else the network or else the servers may be failing. Sometimes some sort of operating systems may be failed. So we cannot predict that when our servers will be going off and when the server works perfectly. So here what happens is that large files will be stored in the format of web documents and they can be processed using batches. That is, one batch can be processed at a particular point of time. And here we'll be having three different sort of operations that we'll be doing on these particular documents. Say, for example, you can read the data or else you can append the data, but we do not allow random writes from the users. We will be allowing them to append whatever the data that is available with them, but will not be allowing the random writes for them. Here, what happens is that whenever you upload some sort of data into a cloud environment, first of all, it will be divided into chunks. And each chunk is of size 64 MB. So, say for example, a file has been uploaded, and as you can see, here it is divided into four different chunks like C1, C2, C3, and C4, and each chunk is of size 64 MB, and every chunk is having its own ID which is of size 64 bit. Now what happens is that as soon as you upload some file into a particular cloud environment, then the files will be divided into chunks and they will be distributed on multiple machines. If you say, for example, this particular server, if you name it as 1, and this is 2, this is 3, 4, 5, and 6, chunk 1 is stored in server 1 randomly, and chunk 4 is stored on server 3, and chunk 3 is stored on server 4, and chunk 2 is stored on server 5. They are not following any sort of order, they are not following any sort of sequence. What they are doing is that they are randomly being distributed among all the available machines. And as we said, each chunk is of size 64 MB, and they can be identified by using an by using an ID which is 64 bit. So that is the main reason we'll be dividing them into chunks. And after dividing the data into the chunks, next what we do is that we'll be maintaining replicas of the chunks. Replica is nothing but, in simple words, we can call it as a copy. So what happens is that each chunk is copied and it is stored in a different location. See, in the earlier slide, we had seen that the data has been divided into four different chunks. Here also, the data is divided into four different chunks, that is C1, C2, C3, and C4. In earlier, here, C1 is stored only in server 1. But coming to here, C1 is also available in server 6. What happened is that they had made a replica, a copy of this particular C1 server, and they had stored in some other machine. You can observe here, they are not storing the data in the same server, they are storing the data in some other server. If you look after C2, it is earlier stored in this particular server 3, and the same copy of C2 is available in server 5 also. The same case applies with C3 and also with C4. What is happening here is that whenever you upload data into a cloud environment, three replicas will be made. Three replicas will be stored in three different locations. What is the use of these particular replicas is that if one server fails, say for example, server 1 fails, then you can access the data of C1 from server 6. And say for example, server 2 fails, you can access the data from the server 4. In the same way, if server 2 fails, uh, then whatever the data C2 that is there, it can be accessed from server 5. So what happens is that in order to ensure the concept of high availability of data, the data replicas are stored in three different locations. And if there is any failure of the server, then obviously you can retrieve the data from other servers also. So that is the main reason that they are maintaining these replicas. And here, if you look after the concept, we'll be having a GFS master. That is, we call it as a Google File System master, who will be maintaining the data regarding the particular chunks. That is, whatever the metadata is there. Metadata, we call it as data about data. That is, which chunk is stored in which server. All the data will be maintained by this GFS master, and it will be acting as an index whenever data retrieval is needed. See, whenever a client wants to retrieve the data, the client sends a request to the GFS master. Here, the GFS master will be containing the table, the information regarding which particular chunk is stored in which server, and after looking after into this particular index, the chunk will be located, and then it will be transferred to the client. If you look after here, the chunk that we had named is it is FFE0, which can be an ID of that particular chunk, and it is stored in server 1, that is replica 1, and the same data is also stored in server 2, that is the replica 2. So here what is happening is that two replicas of data is available. In case of server 1 failure, you can retrieve the data from server 2. That is what happens, right? And this is the diagram which explains on how the reads will be happening in a Google's file system. See, whenever an application or else whenever a client wants to access the data, then what happens is that the file name and also the chunk index will be sent to the GFS master. That is, what is the file name that we want to access, what is the ID of the chunk that we want to access, it will be transferred to the GFS master. Here in the GFS master, what it does is that it will be looking after in which server the actual chunk has been stored. So after locating that particular chunk, the GFS master, what it does is that it will be sending an instruction to the chunk server, and it will be retrieving a chunk server state. A state of a chunk server is nothing but whether the server is in a working condition or not, or else if it is facing any sort of problems. Then, after retrieving the chunk server state, if the server is in a working condition, then the data will be retrieved and it will be sent to the GFS client. And say, for example, here the server state states that the server is not working. Then what it does is that it will be going to the second replica, and from there the data will be retrieved and it will be sent to the GFS client. That is what happens. So if you see over here, the thin lines or else the thin arrows that are represented in in the data, they are all control messages. Nowhere the data is being transferred. They are all the control messages that are being exchanged by the GFS clients to the GFS master and the GFS chunk server. After all the instructions or after all the control messages are completed, then the chunk data is transferred to the GFS clients. That is how our reads will be happening. And if you talk about a write, whenever a particular client wants to write a particular data to a particular server, first what happens is that a client, it will be asking the master that where the data has to be stored. That is, in which server the data has to be stored. The master will be giving a reply to the client, and now the client, what it does is that it will be writing the data to the closest replica. That is, as we said earlier, in cloud, the data will be stored in three different locations. That is, three replicas will be available. Here, what is happening is that first the client will be sending a request to the master that where are the locations of my data, where my data has to be stored. Now the master, what it does is that it will be giving a response that these are the three locations. Say for example, like Andhra Pradesh, Chennai, and Mumbai. These are the three locations that where your data is. Now I am located in Vijayawada in Andhra Pradesh. So my closest replica will be Andhra Pradesh, and after that Chennai, and after that it will be Mumbai, based on the distance from my present location to the other locations. So what the client does is that first of all it will be writing the data to the closest replica, and after writing the data to the closest replica, what it does is that it requests the primary location or as the primary replica to commit the data. That is, from the closest replica, the data will be transferred to the primary replica. And in the primary replica, what it does is that it will be sending the data to the third replica that is available, and here also the data will be stored. Now, what happens is that whatever the primary replica is there, it will be sending an acknowledgement to the client that the data has been stored successfully. That is, say, for example, whenever you are uploading some sort of data into a cloud environment, we may getting a message, data uploaded successfully. What actually happens is that first the data will be written or else it will be stored in your closest replica, and from there onwards the data will be transferred to your primary replica, and from there onwards the data will be stored in the secondary replica, and at last the data will be sent, sorry, the primary replica will be sending an acknowledgement to the client that your data has been stored successfully. As the same in the right we had seen in how the reads we had done, here all these thin line of arrows will be representing the control messages, and the data transfer is represented by using these thick lines. So if you see, the client is sending the data to the replica, nearest replica, and the nearest replica is sending the data to the primary replica, and the primary replica is sending the data to the other replica, and after that the acknowledgement is sent. That is what is happening. The controls are being sent from the client to the replicas, and the client is getting an acknowledgement that your particular data has been saved successfully. That is what happening, right? So here, why do you ensure replica count is that if a chunk master is down, then what happens is that the data will be stored in some other location. Here, the replica count will always be equals to 3. That is, the cloud maintains a minimum of 3 copies of data. Because if, say, for example, this particular server fails, we can retrieve the data from this particular server. And even if this fails, we can retrieve the data from this particular server. Say, for example, this server is down, you can retrieve the data from here. And even if this server is down, you can retrieve the data from here. Meanwhile, what happens is that whoever the network engineers are there, they'll be looking after what was the problem with those particular servers, and they'll be finding a solution, and they'll be planning for a recovery. That is how fast they can get back into the business. We call it as a disaster recovery plan. This disaster recovery plan, what it does is that it will be making sure that the servers will be up again within a very short period of time, because the reputation of the cloud is based on the availability and also the security. If the cloud is not available for a longer period of time, what happens? The customers will be getting a negative impact, they'll be having a negative opinion, that this particular cloud is not up for a major period of time, then why do the customers choose such a cloud? Obviously, they'll be choosing for some other clouds which are more in the market. They'll be migrating to some other cloud. That may happen. So, all the while, what should happen is that whoever the cloud vendor is that they have to maintain 100% uptime, even though if it may not be possible practically that they may be achieving like around some 99.9% or 99.98% of uptime. There may be certain sort of practical problems in every cloud, but we have to maintain an higher upper time when compared to the other clouds. We have to provide a better security when compared to the other clouds. So that should happen. And in order to make this happen, they are maintaining these replicas, and these replicas will be providing us the high availability of the data, even though there is a failure of the servers. Thank you.